Hello everyone. Good evening and a warm welcome to all the participants and the advisors team of ThickNess Learning Community. We ThickNess Learning Community are happy to have you here for the international webinar on control system on AIoT. We ThickNess Learning Community is a new online startup zeroing in on sharing the knowledge through collaborative studies by organizing the expertise and professional talk, inspiring and motivating young minds towards entrepreneurial leadership vision through various programs, and accelerating women empowerment that comes to scale up to the quality of their life. Our upcoming webinars are PCB designing, integration of image processing, artificial intelligence for intelligent system and system development, cybersecurity, etc. With this note, we'll directly dive into our today's session. So today we are going to see about AIoT, the control system in AIoT. Many of you would have heard about IoT, Internet of Things. So today we'll be looking into the control system which is used in the AIoT. Okay, so I'll first share the screen. Okay, and once again, welcome you all for this webinar on control system in AIoT. Today we'll be looking into, this is a beginners friendly webinar, and today we'll be starting with what is a control system, then we'll go to what is IoT, and then we'll see how these both are linked together and see a few examples related to it. Mostly today's webinar will be completely based on examples, because when you relate something to a real-time life, then you'll understand it more quickly and you'll be able to capture it faster because you'll have experienced it. So with this note, we'll start a session today. And first, control system. Before going to IoT, first we'll go with the basic of control system. What is control system? Before going to see how AI enhanced the IoT devices are going to change our world, we'll understand what is the basic concept of control system. We'll go with an example as I told before. In our day-to-day life in our home, we have seen this device. This is a mixie, right? It's a mixer, but it's known as mixie in common South Indian terms. Let us take this mixie as an example. Now, there is a famous South Indian Kerala breakfast dish, which I like very much. It is puttu. It is known as puttu. It is made with coconut shavings, and um, there are two types of puttus according to my knowledge, what I have ate and what I've tasted. There are two types of puttus. The first puttu will have the coconut not charred so minute into pieces. It will be a bit bunchy, which gives you the crunchy feel when you eat it. And the second type of puttu is fully, as you can see here in the image, it's fully charred. The coconut of the second puttu will be second type variety of puttu will be finely charred, and it will go on. So here, if you want to stand in front of a mixie, and you put the coconuts into it, and you will char it. Here, if you see the, you will see how the coconut should be charred, it should be powdered finely or it shouldn't be powdered finely. You are the decision maker there. So, what happens in that case when you do this process is the coconut charving which I was speaking before. What happens there is, this is the simple circuit diagram in which that we can show that. Here you will give the input coconut, then you'll be having your brain to think on what type of what size of the shaving to be. Then you'll give the instruction to see. You'll turn the party. Touching it with your hands and your eyes will see, and those are the sensors. And you'll be again thinking of what is the final product I want and what am I having it here? Is it enough or should I go more or less? Your brain will do all those calculations again. So this is a simple circuit diagram. Yeah. So with this small example of just a mixie, Now let us go to the definition of the control system. That is an interconnection of components forming a system configuration. What are the components which are used in the mixie case? Your brain, the mixie itself, then your hands and eyes or sensors. So what three things are? Controller, that is your brain, which acts as a controller over here. Then the mixie, that is a system, the product or system which being controlled the thing, and your hands and eyes are the sensors. Sensors and actuators, there are two different types of things. We'll look at what is the difference in IoT sector and not now. Uh, now an interconnection of components, the interconnection between your brain, the mixie, and the hands and eyes, that is the controller, the system, and the sensors, forming a system configuration that will provide a desired system response for given input. Well, the input given is the coconut. With these three system configuration, with the three components interconnecting and forming a system configuration, you will get the desired output as the sharpings according to the type of the food you want to make. The best examples for these are human beings, ourselves, animals, few electronic appliances, vehicles, furnace, etc. Because what happens in a furnace is when you heat a furnace, it will check, right? It will have a thermometer inside it. It will check till what amount of temperature should it get heated. If it is not heated to that temperature, it will again sense it that it's not heated. Then it will heat how much it wants. So that happens there. As we have seen it before, this is a simple circuit diagram where the input is coconut. This is input and this is the output. And this brain acts as the controller. See the mixer here, the mixie, it is the system. Yes. And the eyes and sensor, eyes and hands are the sensors. So yes, E. So the basic component, the minimal components which are needed to make a complete control system are only few things. First thing is a controller. We'll look into them detail later. Controller is very important. I'll give a few examples of controllers such as Raspberry Pi, Arduino, all these, Atmega, and more. And then the system, we need a system, we need a controller to control the system, and we need a sensor to find that whether the output is, do we get the desired output or not. Then this thing, this circle here, this is the integrator. Here is error detector or integrator, maybe call this anything. And this will, by adding and subtracting the censored output value and the original input value, the controller will take this data into it and will check whether how much more should I use the system to get the same output. Next, when it comes to system, there are two types of things. One is a closed loop system, another is an open loop system. Okay. Generally, what is a mixie? You put something inside, you on the motor, and it comes out something, right? There, it is an open loop system. Generally, normally in your home, if you see the mixie, it will be like it will not itself see how much it should be sharpened or how much it should be grinded or something. If you put in something, you on the thing, it gets grinded itself. That's it. So that is an example of an open loop system. So as we've seen before, just you'll be having you'll give the input here, you'll get the output. There will be no control system, there will be no sensor in the mixie on how much it is graining or what should be for the output, is it nearby to it or not, all those. Similarly, you can see in the image over here, the bottom, the small, the wheels which are running, it doesn't see whether there's a human standing or there's a person standing on it or not, it just keeps rotating. So this is one of the examples of open loop system. Next, then when it comes to closed loop system, you can see here the same mixie example which I've taken before. You'll have a controller to control the mixie. You'll have a sensor to find the error from the output, and from the input, you'll take the input, you'll take the output. So this is a closed loop system. Can you see the loop is closed here? We are having a closed loop here. So this is a closed loop system. So always the control system, to get the basic ideology of control system is you have to get a desired output. You have to get a desired output. The another example for this open loop and closed loop system is a washing machine. Washing machine is an open loop system because when you put a cloth inside, a dirty cloth inside, it will just wash it and give you, but it won't check whether the stains on it or the dirt on it has been removed perfectly or not. It will just wash it and give you. That's it. But if you make this control, if you make it as with a controller, a cube controller, making it a closed loop, then with the help of a sensor, you have to check each and every cloth inside the machine. Then you have to again rewash it. Then the process continues. So this is a closed loop and open loop system examples. So when you have seen, we have seen that we need closed loop for a control system, and the basic definition of control system is that getting the desired output is the only mode of control system. Getting the desired output is very important for a control system. Next, moving forward, what is a control? We have seen about control system. What is a control first? Control is a process of adjusting the control signal. The signal which is being passed, if you see in the Mixie example from before, you'll get an input, the signal. All these are signals, right? Because the controller knows only about digital signals, plus one or zeros, all those things, computer languages. Control is a process of adjusting the signal such that regardless of the disturbance, the control output of the plant is forced to behave as close to the desired way, always as possible. As you've seen here, with the help, if there is even a disturbance, example, we'll take a different example. We'll go with car. Okay, if we take a car, if the car is going in a road, when there is disturbances, let us check. We'll have a speed constraint. Okay, we'll take a controller to control the speed. Let us say the car should not the car should not go more than 60 km/h. So we place a controller to control the speed of the car. Okay, so what are the factors we will get there? When the car is going in the road, the disturbances, the disturbances will be airflow, because with the airflow, the vehicle direction, in the direction of the motion of the vehicle, in the airflow, the speed can increase. That is a disturbance. Then let us also keep that it should not reduce more than 40 also. So what will happen if there's a small traffic or something? Should find another way to maintain the speed. So the sensors plays a huge role to eradicate the disturbance, eradicate the errors made by these disturbances, external disturbances. So always these sensors play a huge role here. Okay. From more time, from the first slide till now, we have spoke more about error. What is the error? What is meant by error? You can ask me. The meaning of error is very simple. The difference between the input, that is a input reference, and the output response. The input is the reference. The output is the response which we get from. The difference between the input, the output, and the input, that is the error signal. We can tell. So the control is a process of adjusting the control signal such that regardless of disturbance, the controlled output of the plant is forced to behave as close to the desired way, always as possible. Always control system is getting the desired way from it. That is control system. And what is the definition of controller? What is the definition of control system? Control system means that an interconnection of components forming a system configuration that will provide a desired system response for a given input. As we have seen, the system interconnection between components of brain, mixie, and the hand and the eyes, that is the controller, the system, and the sensors. The interconnection of these three components, not only these three, there can be many components in it. We are taking a simple example and we are defining the control system. The interconnection of these components forming a system configuration, that is a closed loop, that will provide a desired response for a given input. The input which we gave in the mixie example was a coconut, and the final output which we got was the sharvings. Okay. So with this limited knowledge of control system is enough for us to go ahead into the IoT concept. Yeah. So before going to that, we'll see another example of the open loop system. Here, we'll take a bread toaster. The input of a bread toaster is a bread itself, and the output will be the toasted bread, right? What happens in the toaster? You just put the bread inside. You will keep the timer, and after the time is ended, it will come out. The input will be the bread and the timer. The output will be toasted bread, right? So how could you make, what are the desired here can you ask me what will be the desired output for a bread toaster? It's a very simple device. It doesn't have so much logical mechanism or something. So what would be the, what would be a desired output for a bread? So if you ask me the desired output for a bread, the desired output for a bread is bread are the color of the bread, the color of the toasted bread. The color of the toasted bread can vary from dark brownish color, that is um, the dark brownish color, to a mild brown color. So this is the desired value. So maximum will be like an average between these two, the dark and the light. So what can be done for each, and here we can add immediately not giving output continuously. When the bread is getting toasted itself, we can add a sensor to check the value of uh, the color of the bread at the that current at that point of situation. What is the value of the color of the bread? So when we find the color of the bread with that with the sensor, then we can send it to the controller and we can check whether how much more is the bread should be added, how much more the bread should be more toasted, what color, how much time will it take to reach the desired color. All those can be easily found out. So going to the next thing, IoT. Coming to the second topic of the day, IoT. As you all know that humans, we use internet for communication. We have WhatsApp calls, we have voice calls, generally known as voice calls rather than WhatsApp call. WhatsApp is a particular device. Sorry, it's a particular app. So we have this voice call. That is the internet for communication. Internet for communication, we text and we use things. Yeah, sorry for the small break. Okay, coming to IoT. Now, similarly, like how we humans communicate to each other through the internet, through network communication. Similarly, think of the devices which we use in our day-to-day life, in our homes. Example, the devices like TV, refrigerator, stove, water heater, water geyser, water heater, then your car, and these devices. When these devices all similarly, yeah, when all these devices speak to each other on the internet, through internet, how will it be? This idea is this terminology. This has a terminology. This is known as Internet of Things. When all the things used in a day-to-day life get connected and speak to each other for the convenience of transferring few data, this is known as Internet of Things. Okay. With this note, we'll try to understand what is Internet of Things. We'll take a small example for this too. This is a refrigerator. This is a normal old model refrigerator. Old refrigerator. Not so old though. It's found in many houses. So in this refrigerator, I guess we can see this. What is general purpose of a refrigerator? It cools the things. It keeps the food items cool and fresh, right? So here you can see it has so many trays, just the trays. Here it has the normal freezer box. Here the egg tray and all. Okay, let us come to an IoT refrigerator. So this is the IoT refrigerator. What can you see there? Here we are having only the just the trays, and just it doesn't read what is inside. Just does its one. It just does its work. That is cooling things. That's it. But when it comes to IoT refrigerator, it will see if you there will be butter, like we have egg tray. It will be having a butter tray or all those. It will see what the amount of butter left out in the tray with its weight when it's kept, and then the zero value in it checks what is the percentage of butter left, and the number of times the door is opened per day, the usage of ice pack usage of ice pack, and will show you the readings, will show you the rate of vegetables and fruits are consumed in home. All these will be done in the IoT refrigerator. So that was a normal refrigerator. This is an IoT refrigerator. So with this, what will be an AIoT refrigerator? What can an AIoT refrigerator do? Now, slowly entering this AIoT concept, first I'll give the abbreviation of AIoT. AIoT is artificial intelligence IoT. That is artificial intelligence plus IoT is equal to AIoT. Then how is this artificial intelligence IoT related to control system? How does it get related to our topic of the day, control system and IoT? How does it get related? The control system which is used in this IoT, that is the AIoT, is the artificial intelligence itself. The artificial intelligence acts as the control system for that IoT. So the basic of control system is the artificial intelligence, and the artificial intelligence IoT mingled with IoT is AIoT. And what work does it do is, as you can see here is the example of it, of AIoT. An AIoT refrigerator will not only check how much butter is left. If the butter is very less, it itself will go to websites like Flipkart, Amazon, or Big Basket, so many others. It will search in all of them. If we go to purchase butter online, we will just be searching we'll just go to one website and we'll buy it, right? But it will search all the available websites and will find the lowest cost in which website is available and will order it for you. So that you will get it. Similarly, the internet enabled, IoT enabled Wi-Fi. IoT enabled refrigerator. So AIoT refrigerator can do all these things, and if it will also intimate you if whether it will give you notification in your phone, and all these things will be done. One of the best example, whenever if you go and ask to somebody who knows the basics of IoT, if you ask them what is an example of IoT, the only thing they'll tell is home automation. Home automation is one of the best example of IoT enabled. IoT enabled. So how does this work? IoT enabled home automation. How does this work? When you wake up early in the morning, like you'll have alarm, right? When your alarm rings, you wake up. When your alarm rings, automatically the geyser in your bathroom ons. Okay, it starts heating the water. After you complete bath, when you open the door of your bathroom, that is when your geyser gets off after your bath, the stove in the kitchen will get on. That is a microwave oven will get on. And this IoT refrigerator, this normal refrigerator is placed inside, will have, you take the things, you cook everything. And when you come out of your home, that is when you lock the refrigerator and come out of the home for going to job or office, the car shutter will be on and the car will be get started automatically. Then after you reach your office, that is when a car gets into this parking lot, your office lights and fans and computer in the office will get on. So it's all IoT enabled. This is reached, so you get on. It's all the communication between them. They share the data between the other things whom we have configured. So now, how is the AIoT coming here in the place of IoT? Now, I'll tell you how it comes. Morning after bathing, you're going to take the things out and cook something, right? How about your refrigerator giving you some suggestions on these are the available items in your refrigerator so that you can cook these things. This food can be made for this many number of people. This food can be made for this many number of people. It will be giving you suggestions on how it can be done things. And when it comes to when you go into the office, after you go to the office, your laptop and things get on, then it will show you the suggestions of the work which you have today. Everything will be shown there. This is IoT enabled. With the difference between the normal IoT and AIoT is the IoT enabling the IoT will give you the more security, and it will also improve the work and the control, the desired output. It will be more. You'll get close to the desired output, we can say. So this is another great example of IoT enabled AIoT. As you can see, with this from the laptop or desktop or pad or phone, you will give the instruction for both these things. When the arm completed its work, then the belt will move. Then the arm completes its work, then the belt will move. All these three will be connected to the cloud. They speak through each other. That is an great example of AIoT enabled. Coming next, as I told you earlier, The sense organs, eyes, nose, ears, skin, tongue, all these are sense organs. That is the sensors. They're an example of sensors, each different type of sensors. For eyes, we have cameras. For nose, we have smell sensor. For ears, we have ultrasonic. So many sensors are there. So with this, the AI, that is the controller, the brain, the sensor plus the brain, the AI is equal to AIoT. This is the best example which we can give for an AIoT. So the difference between an IoT and AIoT, the difference first, as you have seen here, the data will be collected, it will be stored, okay, then will be processed using the data collection will be done using the sensors. Here sensors will be used, SE, then the storage is being made, then the processing. This processing will be done by the controllers, C, okay, then the data analysis will be done. This will also be done by controller only, controller itself. Then it will again continue, right? And here when it comes to AIoT, in AIoT you will be having the AI action. What is the AI action? There are different types of AI actions there. There are few things like fuzzy logic, fuzzy. Then we have normal AI, basics of AI control, and but fuzzy is one of the good or one of the best AI enabled actions which can be done. And these data will be when it's stored and processed, it will learn. The AI will learn itself. We have seen many times, right? Like Google AI. When you speak to when you use Google AI most number of times, it will understand you and start, and it itself will start giving you all the ideas and tips, everything. It collects data, it analyzes it, understands it. Don't repeat the same mistake which has been made in the past. That is one of the greatest things, so that you get the desired output. So that's why AIoT is coming into picture here. So that's it. Thank you. Hopefully you understood the things, and hopefully you're not like how the images, not like carrying so many things in a small duration of time and throwing yourself onto it. You can post your questions in the YouTube chat and will be answered directly by me. Okay, we'll have a small recap of what we have seen till now. First, we saw the control system. What is a control system? The definition of control system using our example of Putu with coconut sharpings, which is a mixie. Then we saw what is a closed loop system, what is an open loop system. And we saw that a closed loop system is always required for a control system. It is the basic of a control system. Then we saw the what is an error. Then we saw what is an error. Then we saw the example of a bread toaster on how the bread toaster, we can make a open loop bread toaster into a closed loop. Then we saw about IoT. We saw the example of a refrigerator. Then we concluded what's IoT in AIoT. Then we saw home automation. Then we saw about the then we saw the sensors, how the sensors are used. So thank you for joining us. And if you have any queries, you can post it here in the chat session, or you can mail us to thicknesslc@gmail.com. Thicknesslc@gmail.com. Thank you.